Hi, and welcome to Geeks for Geeks. Today, we would be discussing GFG Weekly Coding Contest 97. So, before we move forward, let me introduce myself. Hi, and good evening, everyone. I'm Siddharth Hazra. Currently, I'm an SDE at Geeks for Geeks. Apart from that, I'm also a candidate master at Code Forces. So, let's start. So I know that the question changed. The second question changed after a time frame of around 30 minutes. And the problem that came after it was easy. To be honest, I was solving the problems amidst the coding part. Like when you were going contest, I was also solving the problem. And when the question got changed, to be honest, I also got panicked that I would be able to take the stream at 8:30 or not, or would I need more than this period of time to solve up this problem. So but that didn't happen, and I was able to solve before. Just a sec, let me just connect my charging thing. Yeah, but I was able to solve the problem in a time frame of less than 8:30. So hi Sonu Singh, how are you? So can I have a quick one in the chat? If you are in the chat, like let me know if you are in the chat, and we would proceed after a time frame of around 1 hour. So if you ask me about this problem had new things. So the talking about the very first problem, this problem was not very easy. Like the first problem usually is very easy and we can solve it. But this problem required a bit of thinking and the use of bit masking. Moving forward to the next problem, we had like the new problem, which was destroy the garden. Yeah, so destroy the garden, it was a algorithmic problem, and the idea to detect that it was a graph was a little bit intuitive, but on the medium side. The last problem was an absolute beauty, in my opinion. Why? Because expected values and probabilities are the thing which are talked very less in the DSA arena, but they are very frequent, or I can't say they are very frequent, but they are frequently asked on the harder questions of online assessment. So the last problem was very much placed at the correct position in my point of view. हाय भारती, हाय उशर, कियाला, हरीश, हाय सोनू. आज तो मेरे से फर्स्ट प्रॉब्लम भी सॉल्व नहीं हुआ है. या इट्स फाइन, you would be able to solve the next problem. So let's start with the very first. Can I have a quick one, the people watching here? So I have more than 30 people at this point of time. So may I see how many likes I can receive? So number of likes is still 13. So can you please increase the like counter? I didn't find exact approach to which problem. Hi Karthik, hi Priyansh. Okay, so able to get the first one out in the end. Okay, fair enough, no issues. Like this seemed to be the first and the last problem seemed to be on the bit mathematical side, and it seemed like I was giving the Code Forces contest again after a time frame of around 2 years. Yeah, after the time the second question was changed. Yes, the second question was changed. Not able to solve the first one. It's okay. Second one was wrong. No, it was right, but I think they forgot to upload the test case generator. The second question, yes, the second question was changed on the middle of the problem. What about bridges problem, sir? The bridges problem was a little bit good enough. So the first initial bridges problem and the current problem, which was destroy the garden, both were the modular operation in the third question. Sure, I would. So third question involves the usage of binary exponentiation, Fermat's little theorem, and expected value. So basically, the hardcore mathematics is involved in the last question. And the last question was good enough. It would like if I like if you are till like if you are till the end of the stream. Today what I decided was, initially what I used to say is that these are the prerequisite, please complete them and then come to this question. But today what I would try to do is I would try to complete the prerequisite myself in a very concise manner. Okay, so now let's start. Entire screen, and yep, here we go. So the very first one was, so let me just clear all of this. Okay, and I would provide you the code in the editor also. Why? Because the code I am writing is a little bit different. By the way, just a quick reminder to you, the second question got changed. Make sure you raise up this issue in the comment section so that the GFG higher authority also gets to know that. Okay, so now let's start with the very first problem. Yep, add to a new sheet, and here we go. So see, this is told that choose any positive number x and perform this operation at least twice. Okay, add x to your current score and then double the value of x. Okay, so it just means that add x to your current score and double the value of x, and then 4x it would be, then it would be 8x, kind of like this. The challenge here is that you must perform the least operation and you should be exactly equal to k. Okay, so I can say that if we don't know the value of x, if we don't know the value of x dot dot dot, it needs to be equal to k. Okay, fair enough. So let's talk about the very first example. So the very first example, if x is equal to 1, then 1 plus 1 multiplied by 2 is equals to 2, and 2 multiplied by 2 is equals to 4. So altogether we have the value of 7. This is why when x is equal to 1, we can say that yes, this is fine. What is this? This is x, this is 2x, this is 4x. Okay, and it is equal to 7. If you put the values of x as 1, then you would be able to get it. Okay, fair enough. So now the equation is such that we have x added to 2x added to 4x, okay, added to 8x, let's say. Okay, and then we have dot dot dot, and it is equal to the value k. Now what I can do is, as x is common on all of this term, I can say x added to 1 plus 2 plus 4 plus 8, 8 is equals to k. Okay. Now x is equal to k divided by 1 plus 2 plus 4 plus 8 dot 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 dot. This is what you need to find. Okay. This is basically the equation that you need to understand. And if you observe, 1 plus added to 2, added to 4, added to 8, added to 16 is nothing but 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. Okay. So now what you can do is, I observed some of the submissions over the contest. First time I was able to solve up the problem beforehand. Then I was frightened that what if the problems do change again? That is why I was sitting in the contest. So basically what I did was I was checking out the summation of the people. So what you can do is you can add up all these values, okay, and you can get up a new value. But let me tell you a bitwise operation where you don't need to do this headache. Why? Suppose you want the value of 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. This is nothing but 2 raised to the power 4 minus 1. Why? As you can see, 2 raised to the power 2 is equals to 2, 2 to the power 4, and 4 to the power 8. And this is equals to 2 raised to the power 4. 16 minus 1 is equal to 16 minus 1. So 4 plus 2, 6. Okay. 6 plus 8 is equals to 15. And this, okay, I made a mistake somewhere. 2 to the power 0, 2 to the, okay, 2 to the power 0 needs to be also there. Okay, sorry. 2 to the power 0 needs to be also. That is why I thought 2 to the power 0 needs to be there. 2 to the power 0 is equals to 1. So 1 plus 6 plus 8. That is equal to 7 plus 8 is equals to 15. And here also we have the value of 15. Okay. So that is how we are getting up this output. Okay. 2 to the power 0 plus 2 to the power, here also I have written, yep, here I have written correctly, here I have written this wrong. So 2 to the power 0 plus 2 to the power 1 plus 2 to the power 3. If suppose you don't want to add these values explicitly, what you can do is 2 to the power 4 minus 1. So suppose you want 2 to the power 0 added to 2 to the formula would be 2 to the power 1 added to 2 to the power 2 dot dot dot, and suppose you want to go till the value of x. So the formula would be 2 to the power x plus 1 and then subtract 1 from it, and you would get up this value. Okay. So the very first thing that you can do is here. So now what you can do is, as this would be an integer, as this would be an integer. So what you can do is, so as this would be an integer, what you can do is, you can divide the value of k. Okay, let me just, yep, let me do it here only. So this just means that first I would test it for 2 to the power, we need to do two operation. So that means we need to do 2 to the power 0 plus 2 to the power 1. And then we need to check for 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2. And then we again need to check for k divided by 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 and add it to 2 to the power 3. This is how we would keep checking this, and if anyone is able to give a remainder 0, that means x is an integer, we would return that integer. Do I make sense to you? Give me a quick one. Let us quickly recapitulate. The given value was that x is taken, then you multiply the current value twice, okay, and then you need to have k. So x is a common term here. So what I did was I took out this x. Now x divided by k divided by, and we need to check up these all. So now to check up these all, what I can do is I can individually check up 2 to the power 0 added to 2 to the power 1, 2 to the power 2 plus 2 to the power 3. I can individually do that. Or else what I can do is the last value, add 1 to it and subtract 1 from it. Okay, and this would give me the result. Now how it is working, let me just show you also. Suppose we have a value like this. So if we subtract 1 from it, suppose if we subtract 1 from it, then the value would be 111. That is why we are able to have this. This is the intuition of that thing. Okay, the power of 2 looks like this, and if we subtract, it would become something like this. That is why we are able to have this thing. So now do I make sense? Give me a quick one. Now we just need to keep dividing the values. Keep dividing the values. The first value which would make k modulo this as 0, that would be the answer. First tell me if this makes sense or not. इतना हार्ड क्यों डालते हो सर? सॉरी बट आई एम नॉट द वन who is putting up the question. Explain in Hindi also. So Hindi में, so by the way, there is nothing to explain in Hindi. These are pure equations and mathematics. I was not able to solve the got multiple. Okay, but you shouldn't do it. At least see all the questions. 1000 minus 1. No, 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 absolutely not. See, suppose we have 8 minus 1, which means that we can write 8 as 2 to the power 3. 2 to the power 3? I think so. It is 2 to the power 3. Yep. So that means it is 1, 0, 0. Okay, 2 to the power 0, 2 to the power 1, 2 to the power 2. We add 1, 0. This is the binary representation. So 8 minus 1 is equals to 7. Okay, which is also equal to 1, 1, 1. That is equal to 2 to the power 0, 2 to the power 1, 2 to the power 2. This is the binary representation. I'm talking about the binary representation. But if I draw it, I drew it somewhere. Okay, this is the binary representation. X is in binary. Vijayank case. Sorry if I spelled your spelling now. So am I correct? Am I clear to you? Okay, thank you. Thanks a lot. So, sir, problem setter को बोलो थोड़ा first question easy and medium देना. थोड़ा confidence आए. Okay, sure. Just all the queries regarding the contest needs to be put up on the comment section because there is no discuss section of the contest. Make sure you do that. But don't think that I am only the problem setter. I am not the problem setter. I am the mentor who does the post contest analysis. I am just a person like you who is good at giving contest. So he does post contest analysis. So I'm not the one who needs to be blamed. Okay, fair enough. Sure, bro. Okay, so what I can do is the implementation would kind of look like this. Add the stream, accept the challenge, and then what I can do is I need to perform two operations. That means I need to start from int I is equals to 2, and as we know that the value is still 10 to the power 9, so we can just simply go till less than 2 to the power 32 and it would be enough. Okay, we would be getting before it. Okay, and then we would be telling that int temp is equals to 1 raised to the power I. What is this? This is 2 to the power I. What do we mean that? Let me just show you this also. Suppose we have 1. So if we do 1 left shift by 2 would make it 1 0 0. This would be the condition. Okay, 1 left shift by, so let me just add a space in between. 1 left shift by 2 would make it 100. So suppose this is 0 1 2 2 to the power 2, that is 4, which is nothing but 2 to the power 2. See how we are getting it. Okay, and then I told you that we need to subtract 1 from it. So temp minus minus, so that we get all ones, or it is equal to 0 2 to the power 0 plus 2 to the power 1 2 to the power 2 2 to the power 3. And then we say that if it is able to divide the value k, that is n, and so let's have it k only because we are told that we are given k, but here we are in the constraint we are given n. So to avoid confusion, let us use k only. K modulo temp, if it is equal to 0, then we would return the value n divided by temp, that is equal to x. Why n divided by temp? Let me show you that also. So see, k divided by this is equal to x. That is why we are doing that. So n divided by, if at the end also we are not able to find the solution, that means no solution exists, and the solution of this is -1 of 10th minus minus. Okay, I forgot to add here this. Yep. Done. Okay, fair enough. So now tell me the line number at which you are not able to understand. I tried to explain every aspect of this problem, but still, if you have any errors, quickly tell me. Accept the challenge. This is. Please explain the K by temp. Okay. Anything more? Anything more? Anything more? Sir, on campus में इतना hard आता है क्या? Nowadays, the on campus of like the online coding round of the on campus is that this hard. Why you have taken 2 to 32? This is because we need to perform at least two operations. Line number 13, one raise left shift I. Okay. Okay. Let us see what I'm doing at each step. What is the meaning of each step? So see, why I'm going till 2 till 32? First, why 2? Because we need to perform at least twice. That is why 2 is there. Then we are going till the value of 32. Why? Because we know that after 2 to the power 32, the value would be greater than 10 to the power 9. The value would be greater than 10 to the power 9. So it won't affect the answer. Like, let me just show you. 2 raised to the power. Okay, screen is not shared, I think so. Yep. Yep. So let me just show you also. 2 raised to the power 32 is how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 to the power 32 is greater than 10 to the power 9. So we are only going, which is more than k. So we are only going till 31. That is why less than 31. Now, if you see, the number of digits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is comfortable. If you go till 30, it would be very less. Okay. So whenever you think that if we want to operate on integers, go till the value of 32 and you would be good enough to go. Just remember this. Okay. Now the very next thing is why 2 and 32? It is catered. So 2 and 32 is catered. What is this? Okay. This is a bitwise. Like what we can do is if we just do pow 2 to the power I. This is just like let me just comment it. Pow of 2 comma I. If we just comment this out, let me just submit it. Yep, this is also a correct answer. This is a way to get 2 to the power I. If you don't understand that, use this. Pow 2 to the power I. And then as I told, we need to subtract 2 to the power I minus 1. Where did I tell you? Let me just show you. 2 to the power 4 minus 1 is equals to 2 to the power 3, 0 till the value of 3. Okay. Then the very next thing was, this was the explanation of this part. And the very next thing was this. What is all about this? So we found out that it is told that given the value of x, so x plus 2x, so we need to add up this value and multiply it by 2. Add up this value, multiply it by 2. Suppose this is equal to k. So if we take out kx, then the remaining value is 1 plus 2 plus 4 plus 8, and it is equal to k. So if I want to take out the value of x is nothing but k divided by 1 plus 2 plus 4 plus 8, which is equal to k divided by 2 to the power 0, 2 to the power 1, 2 to the power 2 plus 2 to the power 3. That is why we are using k by temp. Okay. And then if we are not able to find the answer to this, we are returning -1. Now tell me if you have any issues or not. Sir, we would go from 2 to log base to if k was greater than 9, 1e9. Yes, absolutely. Using power will be log n operation. Yep, using power would give log n operation, but using 1 left shift by I is a constant operation. And it is considered a very good practice that you use if you want to have just 2 to the power I, then it is considered to be a very good practice of using 1 left shift or right shift. But as many people were not able to get it, so I did. Equation अब समझ में आया, मैं कर रहा था तब नहीं. Thank you so much, Sonu Singh. Okay. Anything more you want to ask? I would be sharing the same thing again. Mhm. I think it is done. Let's move to the next problem. Oops. The next problem would take a comparatively very less time. Okay. So, see, the idea is very understood. Here in this question, I would just explain you the question, then I would tell you the time complexity, then I would tell you what this is all about. Yep, see, the question is that we are given a garden 2, 3, 4, 5, 6, and let's say that these are the health of the garden. We are given the health of each plant. We are given health of each plant. Let me just share the screen. Okay. So in this problem, we are given the health of each plant. Okay. And then we are told that the first and the fifth plant is connected. First and the fifth plant is connected. Then 3 and 4 is connected. That means this is also connected. Okay. So now, if I sprinkle a poison of power 2, then this would end. But if I sprinkle a poison of power 2 as well, a power 6, then it would be able to defeat this also and the connected 6 also. So it's just like this. If you want to understand, करना ये है कि suppose मेरे पास मेरा health 100 है और मेरी girlfriend का health, let's say, suppose I am at a war. Okay, suppose I am at a war. This is me and this is my girlfriend, and we both are connected. So the health of mine is 50 and the health of her is 100. So and we both are connected. So if you poison me with a power of 50, then only I would die. If you poison me with a power of 60, only I would die because her power is more. But if you poison me with a power of greater than equal to 100, then we both would die because we both are connected. So in the same manner, if you just understand this scenario with the same scenario, if you poison this plant with 2, then this would die. But if you poison this plant with more than equal to 6 because it is connected to 6, then both would die. And if you poison 4, then this would only die. But if you poison it with 5, both would die. So to poison these two together, I need a poison value of 6. To poison this individual plant, I need a value of 3. And to poison these two, 4 and 5, I would require 5. So this is equal to 6 plus 9, 6 plus 3, that is equal to 9. 9 added to 5 is equals to 14. That is why the answer we have is 14, and this is how the answer. Am I clear with the problem statement and the test case? Just give me a quick yes or no. Because if the problem because if the problem statement is clear, then this question is a cakewalk. So any other way to solve up this problem? Basically what you can do is, there are other way, like you can find out the powers in different way. Then the very next thing what you can do is, no, there is no other way. The only formula is there. Only a modification you can do is power of 2 to the power I. There is nothing else. So let me give you the implementation of the last problem. Mhm. I was unable to get it. Please repeat this problem again. It is told that, let's say that there are people standing in a kingdom. Let's say, let's remove the question. There are people standing in the question, in the war, like let's say, and these two people are connected. That if you kill up this person, this would also affect this person. If you kill up these two person, this would also affect the other person. And this person is an individual person. So now you need to poison and kill everyone. So now, as I told, that suppose this is me and my girlfriend, if my health is 50 and her health is 100, and if you poison me with a value of 50, only I would die. Why? Because my health is 50, but her health is 100. So she won't die. Okay. The very next thing is, if you poison me with a value of 60, I won't die. So that is why, if you poison me with a value greater than 100, then we both would die. Okay. That is why, suppose I want to kill 2 and 6 together. So I would require a poison of 6. Suppose I want to kill this 3. This 3 is alone, so I would require only 3. Suppose I want to kill 4 and 5. So the max, so to kill 4 and 5 both, I would require a poison of 5, which is very mighty and can kill both of them, which is just this. 6 plus added to 3 is equals to 9. 9 added to 5 is equals to 14. That is why this is the output itself. Now am I clear with the problem statement? Just give me a quick yes or no. Okay. Now, suppose this time I am a group of friend. Okay. Let's understand this problem. Okay. Suppose this is me, this is my friend 1, this is my friend 2, this is my friend 4, this is my friend 5. Okay. The first friend has a health of 1. The next friend has a health of 3. The third friend has a health of 4. The fifth friend has a health of 10. And this is has a health of 2. Let's say these are the health of each one. And we all are connected. Okay. We all like move in groups. Okay. So if you poison me with a value of 4, then this would die, this would die, this would die, this would die, but one would be remaining. Okay. Now, if you poison me with a value of 3, this would die, this would die, this would die, but these two would remain. So, to kill everyone, I need to poison with a value of 10 or more than 10. So, to to kill everyone, I require a poison of greater than equal to 10. Greater than equal to 10. So I can also say to kill everyone, my poison value should be greater than equal to the maximum value of connected connected values. And suppose this person is an individual person, let's say, with a power of, let's say, 100. Then you would require 100 poison to kill up this person because this person is not associated with any other person. Okay? So now I can say that this is a graph problem. How I can say this is a graph problem? See, we found out that connected value. That means connected components. So now I can say 2 has a value, 3 has a value, 4 has a value, 5 has a value, 6 has a value. Now 1 and 5 are connected. This just means 1, 2 and 6 are connected. Then it is told 3 and 4 are connected. 3 and 4 was what? 4 and 5. So I would simply say these two are also connected. So these are connected components. So find out now what you need to do is find out the maximum value of each connected component. This is what you need to do. The maximum value would be 6, the maximum value would be 3, the maximum value would be 5. So I can say that the answer is 6 plus 3 plus 5. So the problem is count the maximum of each connected component, add it and return. So if I write the problem statement is nothing but, let me make it very easy. Count the maximum value of each connected component and return the sum and return the sum. This is what you need to do. Okay, other than this you need to do nothing. Okay, am I clear with the problem? Just give me a quick 0 or 1. Give me a quick. You don't need to bother about that it is 1 based indexing or 0 based indexing. To be honest, it won't affect. So here I would just say it is OL. Instead of this, I would say this is OL. Now, initially I need to build up a graph. So I would have a vector. Okay. I would have a vector of int. Just would declare in the global space so that I don't need to pass the same thing again in the DFS function. Okay. And name it as graph G, and I would have a set to see like many why I'm having this set. This set is a visited array. So consider this as an array. But what happens many a times if we declare a very big array of size n, then many a times I get a TLE because of this. So I don't get a point of doing this. So nowadays I don't declare the size. Okay, if I'm declaring anything in the global space. I don't know why they have this thing. So now as we need to return long answer is equals to 0. So do I need to use LL every time? No, I don't need to use. Or else I would have just defined. Okay. Now I would simply first d dot resize with n plus 1 because it might be 1 indexed, it might be 0 indexed. Let's be on the safer side and consider it 1 indexed. Now, first we would initialize the graph, size of the graph. for int I is equals to 0, I is less than equal to 1, and let me just, okay, it was an, okay, destroy the garden, yep, and I is less than an I plus plus, and we would say g of I is equals to vector int with nothing. Like we would just resize everything to size n plus 1. We are resizing just nothing else. Okay. Now at this point, we would start this. So we would for int I is equals to 0, I is less than m, and I plus plus. Now we would all the connection that we are given in the overlapping array, we would use them as edges. Okay. So we would say int x is equals to ol of I comma 0 and y is equals to ol of I comma 1. Okay, we are done with this. Then we would say g of x dot push back y, because this is an undirected graph, so we would do the reverse of this, g dot y dot push back x, and we have built up the adjacency list. Then we would clear up this visited set, because in the internal implementation it might be a case that they are using a lot of test cases. We don't want to fall into this trap. Now we would design the DFS function. The DFS function is absolutely very easy. So I would say int DFS. We would just call a DFS int v, and then we would say vector int passed by reference, because it is faster. Okay, array is passed by reference, vector is not passed by reference. So first we would find out the node. So value of the node is a of I minus 1. Okay, we are getting the value at that current point. Okay, we are done. Then when this is done, or else, yep. Let's do it b only, and let's pass here 0 indexing. Okay, so for int I is equals to 0, I is less than n, and I plus plus. If it has not been visited dot count of I. If I have not encountered this, if I have not encountered this, I would say visited dot insert I, then answer plus is equal to DFS of I. Okay, at the end I would just return the DFS. I would return the answer. Yep. Here we just need to find the value of, here we just need to find the maximum value in the connected component. We just need to do a DFS, nothing else. So first we would, so when we have a node, we would first visit it. So visited dot insert the value v. Okay. Then we would say for auto ng of g of v. We are accessing the neighbors. If this neighbor is not visited, so I would just copy this. If this neighbor is not visited, if this neighbor is not visited of count of ng is not there. If neighbor is not visited, then visited dot insert ng. Okay, then visited dot insert ng, and then we would return up this value. Okay, so I would say val is equal to max of, like we are inserting here, we don't need to insert here again, maximum of the current value and DFS of its neighbor with the same array again. and this is 10, and then you would return the value. We need to use here as int only. Yep, int should work. Let us just compile and see how many errors am I making. Okay, we have a lot of errors. Answer plus is equals to dfs of I comma a. Now let us just compile and run. We have your output is 15, but the expected output, let's just make this as 1 and less than equal to n. Let's just have it v answer of v minus 1. Now this should work. Yep, done. So now tell me the point. So this is using DFS. So learn about connected components if you're not able to understand this. And if you're not understanding this part, this is building up the undirected graph if there exists a path from my homes to my girlfriend's home. As this is an undirected path, so she can also visit my house. So if there is a path from x to y, there would also exist a path from y to x. That is why this is an undirected graph. Then if this path is not visited, this node is not visited from any other connected component, then we are doing a DFS from that point. Okay. This was a variation of a very standard problem. So now tell me the line number at which you are not able to understand. Destroy the garden. Yep. So just tell me the line number at which you are not able to understand. Till then, I would just give you the link to this problem, link to the solution, because many people are asking for my implementation also. Mhm. Give me a quick one if this is understood, else give me a 0 in the chat. I would wait for the next 30 seconds. Let me just check the previous screen. Okay, we have 36 watching at this point of time. Y val v minus 1. Okay, let me just cater this also. So while v of n minus 1, it is because of this thing, that val of c. Here it is told 1 and 5, but in reality, it is telling me that index 0 and index 4 is connected. Index 3, index 2 and index 3 is connected. This is telling me this. So it is 1 based indexing, but we want 0 based indexing to access the value of the array. That is why we have this. So here it is given 1 based indexing, but we need to operate on 0 based indexing because only 0 based indexing work on the array itself. Now am I clear? Didn't get the DFS part. So if you are not getting the DFS part, then I think you need to learn the DFS thing. Like this DFS part is a little bit easy to understand. Let me just show you this. Mhm. Okay. Suppose there is a connected component of 1 to 2, 2 to 3. Okay, let's say the connected component is like this. So for 1, in the 1, the adjacency list, it would be stored 2, and in 2, the adjacency list would be stored to 3, and 3, the adjacency list would be stored to 2, and in 2, the adjacency list would also store 1, because this is an undirected graph. So how are we doing the DFS part? Let me just show you. Suppose 1 is passed. So from 1, 2 is, so initially no one is visited. So first I would visit this one. Okay, I would visit this one. And then the neighbor of 1 is 2. So I would visit this 2 also. Now from 2, I need to go to 3. So I would go to 3 also because it is unvisited. Okay. Then 1 is already visited. So we won't do anything. So we would start. This is how we are visiting each term. And while we are visiting, we are taking out the maximum. See, if you observe, let me just remove this. Yep. See, first we are getting up the value. Okay. Then we are visiting the node. And then we are visiting its neighbor if it is not visited. See, if it is not visited, then only we are visiting the neighbor. At each point, we are considering this value with the value that is returned from this point. And then we are returning. So let me just show you this also. Suppose this is 1, this is 2, and this is 3. Okay. So val is equals to 1. So now val would be equal to 1. Then 1 is visited because of this. Then we would go to the neighbors of 1. Neighbor of 1 is 2. Okay. So if we do a DFS of 2, then we would only visit 2 because the neighbor of 2, that is 1, it is already visited. So it would return me true. So maximum of 1 comma 2 is equals to 2. So this value would be updated. Then the next neighbor of 3 would come into picture. The next neighbor of 3, we would do a DFS. This would be visited. 1 is already visited. So 3 comma 2, the value which is already there, 3 comma 2 would make it 3. That is how we are getting up the maximum value. This is very simple. Like if you understand DFS in depth, then you would understand this. भैया smart लग रहे हो, keep up this look. Okay, am I clear to you, Animesh? Okay, भैया smart, thank you so much. But many people don't like it. Like I am getting a lot of bashing from my friends and all. That now I don't look like a mentor. Okay, fair enough. Now let's move to the last question. The last question was a very great question. Okay. So before we say that find the expected number, before we say this, okay, before we say this, have I given you the ID link? Yep. So before this question is all about finding the expected values. Okay. So to find the expected value, we need to first understand what is expected value. Many people won't be knowing it. So you can learn up this expected value from this. I personally learned from this. Okay. If you ask me, I got a question over Code Forces contest where we had to find the expected value. I was not able to understand, and after that, I searched at and all. Then I saw that I need. So I learned from this. I'm not telling you to learn from this. I'm just telling you I learned from this. Okay. I'm just telling you my personal preference. Okay. So let's move forward. What is an expected value? In brief, I would just explain this part because only this part is needed. But if you are getting deep into programming or this whole competitive programming thing, then consider learning till the very end, which is the contribution technique as well as solving up all this problem. Make sure you do this. So it is told that, let me take a snippet of this. So the expected value is the definition of this. Okay, what is this all about? Let's say, suppose it is given, suppose I went to the shop, okay, and I found a ticket of 2 rupees. I would just convert the dollar to rupees because most of us are Indians here. Suppose the lottery ticket rate is 2 rupees, okay, and it is told that I can win 10 rupees with a probability of 10%. How much is the probability? 10%. And I can win 20 rupees with a probability of 2%. Now, what is the expected value? Okay, what is the expected value? So the expected value would be 10%. If we just convert it, it would be 0 comma 1, because 1 by 100, 10 by 100. So what is this? So I would just tell you this: 10 divided by 100 multiplied by 10 added to 2 multiplied by 100 multiplied by 20 rupees. So zero point 0.4. So we are getting 1.4. So on an average case, if I buy up a ticket of 2 rupees, I can say that I would earn back 1.4 on an average. And this is known as expected value. Okay, it is the sum of the probabilities. Sum of the probabilities is the expected value of a particular thing, kind of, you can say. Okay, this is expected value. Okay, this was a prerequisite, but I tried to explain what is needed because this is what is programming. Okay, learn on the go. Okay, now it is told that Geek found a magical tree that has the capability to regrow apples every second if they are plucked. Okay, the apple tree is denoted by V and E edges that represent the apples present at each node. Okay, so let's take up this graph. This graph is very interesting. And let's make this all as black as of now. Okay. So now it is told that I can, this is the graph, and at each node I am given some number of apples. And I can be in this graph for k seconds. And here the value of k is how much? 2. The value of k is 2 itself. Okay. Okay. Now it is told that if the value of k is equals to 2, then we would start, like, we can start from 1 also, we can start from 2 also, we can start from 3 also, we can start from 4 also. Why? Because as we have seen, expected value is the sum of all the probabilities. So now what we can do is sum of all the probabilities. So let's say that I would start from 1. Okay, if I start from 1, I would gain 1 apple. Then I can go to 2 also, I can go to 3 also. Okay, either of the ways. So I can say that I have two options. So if I have two options, suppose I have option A and the option B, and I need to select one option. So the probability of a particular option being selected is 1 by 2. So number of option divided by 1. Suppose I have 5 option. So the probability of getting a particular option selected is 1 by 5. So in the same manner, I would say I got 2 options from 1. So I have a probability of 1 by 2 multiplied by, if I go on either of this, I would go, if I select 2, I would get 1. If I select 3, I would get 1. So in total, I would be earning about 1 plus 1 by 2 by 2 is equals to 1. So in total, I would be earning 2 if I start from k is equals to 1. Am I clear with this? First tell me. And then we would start from 2, then we would start from 3, then we would start from 4. And the sum of all of them would be the final answer. Okay, I would start again. Okay, so given I can remain in this tree for 2 seconds. So if I start from this 1, I would be able to pluck one apple. And then I have two options. Either I can move to 2, I can either move to 3. So suppose I have two options. Then suppose I have A and B. A and B. So for a particular option to be selected, the probability is 1 by 2. So I would say the probability is 1 by 2. So if I go to the second value, I would earn 1. And if I go to the third value, I would again earn 1. Okay, in both the scenarios, I would earn 1. After this, I would exhaust k is equals to 2. So the final amount would be 1 plus 1 by 2 multiplied by 2, and it is equal to the value 2. And this is the value if we start from the first node. Okay, this is what is given. Do I make sense to you now? Summer is coming up. I'm getting drenched in respiration again. So am I clear with this? He is in question 3. Yup, I'm in question 3. Now, let's say I start from the second. Okay. So I would earn one apple. Then from second, I again have two options. So that would be 1 by 2. If I go to the first, then I would earn 1. If I go to third, I would again earn 1. So again, it would be that the value would be 2 if I start from the second node. Let's start from the third node now. So if I start from the third node, it would be 1 again. Then from 3, I can go to 3 other nodes. So 1 by 3. And if I go to 4, I would earn 2 apples. If I go to 1, I would earn 1 apple. If I go to 2, I would earn 1 apple. So the value would be 3 plus 1, 4. 4 plus 1, 1 plus to 3, 3 plus 1, 4, 4 by 3, 1 plus 4 by 3. Okay. Now if I start from the fourth node, I would be rewarded with 2. Then I have one option only, that is 1. So I would be rewarded with a value of 3. So the answer would be 2 added to 2 added to 1 plus 4 by 3 plus 3. Okay. Let me just write it in a bit good manner. Okay, sorry. So I can say that the value would be 2 added to 2 added to 1 plus 4 by 3 added to 3. And then This is for all of the node. So for a particular node, this would be 1 by 4 multiplied by this would be the answer. That is why the answer is this. Yes, second answer can be done using DSU. That is why we have this answer. Okay. So now let us first discuss two things. Okay. So the very first thing is that how to solve up this problem, and the very next thing is how to do this modulo thing. First, let me tell you how to solve up this problem, and then we would handle the modulo thing explicitly. Okay. So now the very first thing that you need to do is like you need to explore all option. You need to basically explore all option. Like from each of the node, you need to start. From each of the node, you need to start. You need to multiply. This is what you need to do. So basically, you need to explore. I don't like this. Okay, yeah, I like this. So I need to explore all ways and I need to return the sum. This is what I need to do. So whenever I come to the conclusion that I need to explore always, I would say that it is recursion. So as we know, the time complexity of recursion is very high, and this won't fit in the given time complexity of 10 to the power 5 or something. So we need to optimize it, and we would say that this is dynamic programming. Now, how it is dynamic? So how to solve using dynamic programming? Let me just tell you. So what we would do is we would just do dp of a particular node dash k, and this would tell me that sum till k, sum till node when k is there. Okay, sum till the node when k is there. Other than that, it is not possible. Okay, fair enough. This is what is asked in this question. Do I make sense? Give me a quick 0 or 1. Most welcome, Ferio. Okay, so now how would we do this? We can simply do by a DFS, simple DFS, and we can just memorize it. Memorize this one. Okay, how to memorize this one? We would start from 1 and we would visit 2 also, and we would visit 3 also, and we would just sum up all those values and we would get this value. Then we would start from 2, we would go to this also, we would go to this also, we would sum up those values and we would be getting this. And each time we would be saving the values. Okay. Now the very next question is how to do modulo. Okay. So see, modulo A by B modulo M, if it is given, then we can't apply directly modulo over this. We need to apply A multiplied by B inverse, B inverse. So this would be A modulo M, then B modulo M, and then whole modulo M. And this would be the formula of this. Now you would be wondering, what is this B inverse? How to get the value of B inverse? So now whenever this given modulo is a prime number, then finding out the inverse is very easy. Okay, now I would be going a little bit quick because this is a prerequisite. If you don't understand, I would be giving you all the links. Make sure you go out and read this and can come back. Okay, so now this is inverse. So the inverse is given by Fermat's little theorem. Okay, which is if I want to find A inverse and the given modular value is a prime number, if M is a prime number, by using Fermat's little theorem, we would say A is equals to M minus 2 mod M. Please remember this. So I can say that the given value would be A modulo M multiplied by B raised to the power M minus 2, then whole modulo M, and this is also modulo M. Okay, so A by B modulo M is equal to A modulo M multiplied by B modulo, sorry, B raised to the power M minus 2 and whole modulo M, and this whole thing modulo M again. This is by using Fermat's little theorem, and now we are going on a little bit advanced thing. Okay, this is there. So now, as you already know that the value of M here is 10 to the power 9 plus 7. That means this value would be 10 to the power 9 plus 5. 10 to the power 9 plus 7 minus 2 is equal to 10 to the power 9 plus 5. So A raised to the a very large number, A raised to a very large number would be very big. Okay, suppose we want to do 5 raised to the power 25. So it is a very large number. So this means that we would be multiplying 5 25 times. Okay, 25 times. But there is an easy way to do that. Okay, the idea is by using binary exponentiation. So let me just search it and give you also binary exponentiation. This is the article. Make sure you read this. Okay, this is the learning material for this. So now binary exponentiation tells us that 5 multiplied by 25. Let's say that I want 5 multiplied by 8. Let's take a small number. So just see how many number of operation we are doing. So I would say 5 multiplied by 5 to the power 4. I can do this operation. So this was one operation. And now I can say 5 multiplied by 5 multiplied by 5 to the power 2. This is the second operation. Now I can say 5 multiplied by 5. Sorry. So I can say that this is 25 multiplied by the power 4. This was one operation. And then I can say 125 to the power 2. This was the second operation. Okay. And the third operation is 125 multiplied by 125. And we would get up this value, which is equal to, if you observe, 5 raised to the power 4 is equal to 25. 5 raised to the power 5, 125. Oops, I made a lot of mistakes. 25 multiplied by 25 is equals to 625 to the power 2. Okay, this is, so now this would be 625 multiplied by 625. Yeah. So how many operations we were doing? We are just doing 3 operations. So 5 can be written as 25 to the power 4, and and this value can be written as 625 to the power 2. And now if you observe, by doing 3 operation, I can say 625 multiplied by 625 is equals to 3953125. This is a very large number, so I am also okay. So 325, sorry, 396 396. Remember this, and then 5 to the power 8, 396. So instead of multiplying 5 8 times, by doing 3 operation only, we were able to complete this. Let me just show you one more example. Suppose I want to do 3 raised to the power 7. So I can say that 3 raised to the power 6 multiplied by 3. And again I can write 3 multiplied by 3, that is 9. 3 multiplied by 3 to the power 3. And I would just do this. Now again I would take out this. So whenever we have an odd value, we take out an element, and whenever we have an even element, we multiply the inner value with the same value again. Okay, this was binary exponentiation, this was modulo inverse, and Fermat's little theorem. So basically we are doing a hell lot. That is why this seems a little bit difficult to understand. So if you're not able to understand, consider watching the stream in a little bit slow and just read up and then come back. Did I make sense to anyone? Okay, we have a very less audience. Okay, just 20. So I think, so by the way, if you're watching this stream at this point, I took a lot of effort to tell you from where it can be learned. I didn't leave you in the midway. So in return, what you can do is you can, if you're watching the stream in the recorded version, you can just write the thanks at this point when you got something to learn. Okay. So we would have a visited array, same like the previous, and then we would have the same destroy the garden, like the same. We would just build up a graph here. Okay. This is expected value. No, we are already given the graph, but we need the graph. What do we require? Set. Okay, just tell me if things are clear to you or not. Just tell me. Quickly tell me, sir, you are a fan of. No, of course not. So, quickly tell me if this thing is clear to you or not. I would be waiting. Like, let's quickly tell me if things are clear to you or not. Mhm. Okay. So, there's a lot very. So, I would first code up the binary exponentiation part. So, this question was kind of a little bit difficult for many DSA coders. But for competitive programmers, this would have been a little bit easy. So now let me just code it with binary exponentiation. So I would just say binary exponentiation bin cow. Okay. Bin, or let's just write an exp exponentiation. And here at this point we would be having long a comma long b with the power of in long mod. And here at this point we would say int mod is equals to, we would define a mod at this point, and let's say long only. Why to take confusion? Long mod is equals to long of 1 e9 plus 7. This is done. And then we would require the graph also. So vector int vector of int, and we would name it as g. And then we would also require the 2D DP array to store the value of n cross g. First we would code up. the binary exponentiation part. So we would say long answer is equals to 1. Okay, and then I would say while b is greater than 0. Okay, so if it is an odd value, if it is an odd value like 1 and b is equals to the value 1, I would say answer is equals to answer multiplied by a modulo mod. Okay, and then I would just b is equal to b left shift by 1, or else you can just do it here only. If you're not understanding what this function is, make sure you understand this thing. This is same as this. I'm just copy pasting this. Okay, and then a, a is equal to a is equal to sorry a is equal to a multiplied by a modulo mod. This would be done. At this point I would return the answer to the system. So now I would code up the main function first. Okay, binary exponentiation, this small thing is done. So first I would build up the graph. So adj of v plus adj dot resize v plus 1 done at this point. Then we would go for int I is equals to 0, I is less than v and I plus plus, and then we would say g of I is equals to, first we would empty the vector, we would initialize the vector because we have not defined a size at this point. So first we would define the size of the vector. Okay, then we would go to the edges, and then we would have an edge to x and y. So for int I is equals to 0, I is less than the number of edges and I plus plus. Okay, then I would say int x is equals to edge is e of I comma 0, and then int y is equals to e of I comma 1. Okay, then I would say g of x dot push back the value of y, and g of y dot push back the value of x. Now after this is done, we would initialize the whole dp array to 0. So now long num is equals to 0. This is not required, I think. Yep. Oops. Yep. This should go on this side. Fair enough. And then we come at this point. Then we would say dp of assign, like we are making all the values, like we are defining a 2D dp array with everything as -1. So just we are declaring a dp array of size v cross k with everything as -1. Vector int k plus 1 with the initial value of -1. This is vector, define vector size. See, this is a way, see, this is a way of 2D vector. Okay, like you can define a 2D vector like this way. This is done. Now after this we would say for int I is equals to 1, and then we would go to everyone. Okay, we would go to everyone out there. k plus 1, the value of k is smaller, no? Okay. Do we have any issues up till this point? And then we have I plus plus. Okay. At this point, I would say num is equal to num plus dfs of a comma I comma k and then whole modulo mod itself. Okay. After all this is done, we would return the value in integer. Like we would just typecast it to an integer. So how many viewers are there at this point? We have 18 viewers. Okay, very less dropping at this point. Like people who are already there are already there. Number. Okay, let's not do this. Like let's just code this DFS part and then we would solve up this problem at this part. So the DFS function at this point becomes very easy with everything as bin pow and all. So now we would say vector int pass by reference a, and then we have the node as node, and then we have the value as k itself. So first we would say if k is just 1, then we would take up that value and return. What do we meant by this? So see, this would be the base case. If I am, suppose if the given value is 1 second only, so I would take up this value and I would return from this value. So I would say k is equals to 1, return a of node minus 1. Okay, and this is just a memorization. If dp of node dash k is not equal to minus 1, then return dp of node dash k itself. And at this point, we would initialize an answer of int. So first, we would find the long. So we would say long number is equals to a of node minus 1. Okay. And then we would multiply it with 1 ll. Typecast it to a long. And then we would again multiply this value to g of node dot size. Why I'm doing this? Let me just tell you this also, g dot node dot size. Because see, from 2 I can go to 1 also, 3 also. Why? Because the degree of 2 is 2. From 1 I can go to 3 other nodes. Why? Because the out degree of 1 is 3. From 3 I can go to 3 other nodes. Okay. Why? Because the degree. So degree are the number of directly neighbors. So to find the degree, we don't need to do it explicitly. Rather, this is just the degree. Multiplication of degree. This is this. Please understand that. This is a very confusing thing. This is the memorization part. You would understand. K is equals to 1. You would understand. This is because we are multiplying the degree with the current value. If this is understood, then this whole problem is understood. And then we would be iterating on the neighbors for auto ng of g dash the value of node. And then we would say num is equals to num is equals to num plus dfs of a comma ng comma k minus 1, because at this point k would reduce at this point. Okay, and then modulo mod. Okay, now this part is very interesting. At this part, we need to do 1 by 3 multiplied by this. We are having a fraction value. So this is just like 1 added to 4 multiplied by 3 inverse. This is what we are having. So at this point, we need to use inverse. What was the formula of inverse? I told you that A inverse is equals to A by B modulo M is equals to A to A modulo M multiplied by B to the power M minus 2. B to the power M minus 2. Please remember this modulo M. So I told you that we would return, first we would assign dp of, the answer would be node dash k is equals to an integer value, because we have initialized the dpr as integer. Okay, we would say an integer value of what, num multiplied by the exponentiation of the sum of this particular node dot size, the degree, comma, mod minus mod minus 2. Okay, and then we have the modulo thing, and then we have the whole modulo mod, and we would have a comma at this point, and then we would return dp of node comma k. And at this point we would do the same thing. Okay, degree multiplied by this. So what was this? See, we had here 1 by 3. 3 is what? 3 was the degree. 3 was the degree from 3, na? So that is why the out degree multiplied by the out degree, we need to find the inverse of an out degree. So inverse of out degree would be out degree to the power mod minus 1. This would be the inverse of the out degree. Let's start. Now the last line, what we would do is, we would at this point, we would say that return the same thing. What we have done at this point, we would do the same thing at this point, just change a little bit of code. Okay, the change would be return num multiplied by exponentiation of the whole value to the power mod minus 2. Why? Because at the end what we did was, if you just see, this was 1 by 4 multiplied by this. So this would be this value, whole value, and we need to modulo 4 inverse multiplied by 4 inverse. So we need to find the vertices inverse. We would need to multiply the answer with the vertices inverse, and that would be my answer. That is why I did this. Okay, so now this time I won't be giving you time to read and ask me, because this should take a lot of time. This is a very big code. So consider asking the doubts of this question in here. And if you want a faster resolution, then what you can do is, you can simply, like, this is the code, go home, analyze this code, and then you can ask me the problems related to this code. If this stream is more than 24 hours late, so if the stream is more than, like, the stream was more than 24 hours, consider asking your doubts by going on my LinkedIn profile. Okay, because after, like, I do a lot of live stream, I do every week, I do live streams, so I don't remember, so I don't, like, I don't can't go and check all the previous live streams of mine. So at this point of time, I do a lot of live stream. So kindly understand that it's not that I have an ego or something. It's because I have a full-time work. I have a personal life. When I do streaming and all. So it's not possible that I go on all my previous videos and search over the comments over the video. That is why if you have an issue and the time frame is more than 24 hours, consider going to my LinkedIn profile and asking me. That's it for today. So that was from my side. So I tried to move forward with all the prerequisite. Like, only exception was I didn't explain you the basic graph properties, and explaining basic graph would make the stream go to 3 or 4 hours. Okay, and many people won't be justified. That is why I tried to make it as user friendly as possible. I If you were able to learn few things from me or from the stream today, consider liking the video and commenting on the video so that the reach of this video could be increased. And after the stream, I could see some comments and I can smile at this point of time. Thank you, everyone. Good night and all the best. All the best for your future endeavors.